we need to solve the following differential equation. Let us begin by rewriting the given differential equation as dx over dy equals to x times e raised to the power of x over y plus y whole divided by y times e raised to the power of x over y. Now, this is, let's say, it's our function f x y. If we make the substitution x with lambda x and y with lambda y, then we will see that this is going to give back the original function f of x comma y. And when this criterion is met, we say that our function f of x comma y is a homogeneous function. So that means this is a homogeneous differential equation. However, in order to solve this differential equation, we cannot use the method of variable separation. That's because our function f of x, y, this cannot be expressed as the product of two functions, g and h, where g is purely a function of x and h is purely a function of y. However, what we can do here is, if we make the substitution x over y equals to a variable v, then we can reduce this differential equation to a variable separable form. So let us do that. So here x over y equals to v can be also written as x equals to v times y. And we will take the derivative on both sides with respect to y. So this will give us dx over dy equals to v plus y times dv over dy. All we have done is apply the product rule to v and y. We will use this value and this particular value and rewrite our given differential equation, which will give us v plus y times dv over dy equals to, so we have x here, so in place of x we have v times y multiplied to e raised to the power of x over y. So this will become v plus y divided by y times e raised to the power of v. What we can do, we can factor out y from both the numerator and the denominator, and this is going to leave us with v times e raised to the power of v plus 1 divided by e raised to the power of v. Now let us take the v from the left hand side to the right hand side. So we will be left with y times dv over dy on the left hand side, and on the right hand side we have v times e raised to the power of v plus 1 over e raised to the power of v minus v. We'll combine these two terms. This will be e raised to the power of v in the denominator, and in the numerator we have v times e raised to the power of v plus 1 minus v times e raised to the power of v. So here v times e raised to the power of v term gets cancelled away, and we are left with 1 over e raised to the power of v, and this can be rewritten as e raised to the power of v times dv. This is equals to dy over y. So what we have here is a variable separable form, and it's a very easy integration that we can perform. The integration of the exponential function is the function itself. We have e raised to the power of v equals to integration of dy over y. So that will be natural log of absolute value of y plus the constant of integration c. Finally, what we'll do, we'll substitute the value of v with x over y. So we have e raised to the power of x over y equals to natural log of y plus c, and this is the required solution to our given differential equation.